Hello and welcome to Weekly Dev Tips. I'm your host, Steve Smith, aka Ardalis. This is episode 28, entitled Applying Pain-Driven Development to Patterns. Don't forget you can follow Weekly Dev Tips on Twitter, as well as in your favorite podcast app, and if you're finding these tips to be helpful, please take a moment to leave a review wherever you're listening from. I read and appreciate every review. This week we talk about specific ways you can apply my strategy of pain-driven development to the use of design patterns. This is an excerpt from my Design Pattern Mastery presentation that goes into more detail on design patterns. I talked about pain-driven development, or PDD, in episode 10. Check out that episode first if you're not familiar with the practice. I've recently been focusing a bit on some design patterns. An easy trap to fall into with design patterns is trying to apply them too frequently or too soon. PDD suggests waiting to experience pain while trying to work with the application's current design before you attempt to refactor to improve its design by applying a design pattern. In this tip, I'll walk through a few common steps where applying a specific pattern may be helpful. To begin, let's assume we have a very simple web application. Let's assume it's using MVC and there's a controller that needs to be used to return some data fetched from a database. It could be an API endpoint or a view-based page. The UI format isn't important at this point. The absolute simplest thing that you can do in this situation is hard-code your data access code directly into your controller. So, assuming you're using ASP.NET Core and Entity Framework Core, you could instantiate a DB context in the controller and use that to fetch the data. This works and meets the immediate requirement, so you go ahead and ship this version. Time passes, and a little bit later your application has grown more complex. You have some filters that also use data along with other services, and you start to notice occasional bugs from EF and realize that you've introduced a bug. By instantiating a new DB context in each controller, but occasionally passing around entities between different parts of the application, EF gets into a state where entities are tracked by one instance of a DB context, but you're trying to operate on them with another DB context. You need to use a single EF Core DB context per web request, which is to say it should have a scoped lifetime. Fortunately, ASP.NET Core makes it very easy to achieve this by configuring your DB context correctly inside of Configure Services in Startup. In fact, if you don't read the docs, you probably don't even know what lifecycle EF Core is using because it's hidden within an extension method. In any case, once you configure DB context in Configure Services, you need a way to get it into your controllers. To do this requires the strategy pattern, which we covered in episode 19. If you're familiar with dependency injection, you've used the strategy pattern. Add a constructor to your controller, pass in the DB context, and set a private local field with the value passed into the constructor. Do this anywhere you're otherwise newing up the DB context. Remind yourself that new is glue. You just fixed an issue with too tight of coupling to the instantiation process by using this service collection built into ASP.NET Core, which is an IOC container, essentially a factory on steroids. Your EF Core lifetime bug is now fixed, so you ship the code. Some more time passes. The application has grown, and now there are a bunch of controllers and other places that all have DB context injected into them. You've noticed some duplication in how your code works with the DB context. You've also found that it's tough to unit test your classes that have a real DB context injected, except by configuring EF Core to use its in-memory data store. This works, but you'd prefer it if your unit test truly had no dependencies, so you could simply test behavior, not low-level data access libraries. You decide that you can solve both of these problems by introducing an abstraction using the repository pattern, which is just a fancy name for an abstraction used to encapsulate the low-level details of your data access. You create a few such interfaces, implement them in new classes using the DB context, and then make sure your controllers and other classes that were directly using DB context now have an interface injected instead. Along the way, you fix a couple of bugs you discovered that had grown due to duplicate code that had evolved differently, but which should have remained consistent. When you're done, the only types that know about DB context directly are your concrete repository implementations. Some more time passes and your application has grown more popular. Some of the pages are really hammering the database. That data doesn't change very often, so you decide it's a good candidate to add some caching. Initially, you start putting the caching logic directly in your data access code in your repository implementations that use EF Core. But you quickly find that there is a lot of duplication, and your once simple repositories are now growing cluttered with a lot of caching logic. What's more, changing the details of what is cached how is requiring you to touch and retouch the repository types again and again. Your current approach is obviously violating both the single responsibility and open-closed principles, two of the solid principles. You recognize that you can apply the decorator, or you could consider it to be the proxy, pattern by moving the caching logic into a cached repository type, which you can choose when and where to use on a per-entity basis simply by adjusting the type mapping in your application's configure services method. With this in place, you're able to quickly apply caching where appropriate and ship a better performing version of your application. Over time, as you built out your repositories, you kept basic methods for creating, reading, updating, and deleting entities in one place. Maybe you implemented a generic repository or used a base class. You were careful not to expose iQueryable interfaces from your repositories, so their query details didn't leak all over your application. However, to support many different kinds of queries with different filters and including different amounts of data from related types, you found that you needed to add many additional methods and overloads. In addition to a simple list method on your order repository, you needed list by customer, list by product, list by company, not to mention things like list with order details, and other variations. Some of your repositories were growing quite large and included quite a bit of complex query logic, which wasn't always easy to reuse even between methods in the same repository. To address this pain, you apply the specification pattern, which treats each unique query as its own type. Using this approach, you're able to create specifications like orders by customer, orders by product, and orders by company, which included the appropriate order details if desired, or supplied an option to specify whether or not to include it. Your repository implementations after this refactoring drop down to just simple CRUD methods, with the list method now taking in a specification as a parameter. Hopefully this helps you see how you can recognize a certain kind of pain or code smell and respond to that pain by refactoring to use a specific design pattern. If you keep your code clean and simple, it's fairly easy to do this kind of refactoring as you need it, so there's no need to try and use every pattern you know speculatively as you begin a project. The pain-driven development approach is obviously very closely related to the idea of YAGNI, or you ain't gonna need it, that was popularized by extreme programming. That's it for this week. Hope you enjoyed this episode. Thanks for listening, and we'll see you next time on weeklydevtips.com.